Let's solve another set of integrals with the method of substitution. To remind you, method of substitution works well with radicals and trig functions. So far we will keep working with radicals, and then I will move to trig function, maybe next video. Okay, so question number 1. We have square root x and cubic radical of x squared minus a degree, radical degree 4 of x dx. All right, so let's see, what do we have? X to power 2/3, right, in denominator, and x to power 1/4, right? Okay. What is going to be common denominator between these 2/3 and 1/4? 12, right? So this is what I'm doing. I'm taking x, that is equal t to power 12. Okay? So from here, in x is equal 1. So from here, if the x to power 1 equal t12, then x to power 2/3 is equal x to 1 times 2/3, right? And from here, I'm doing t also 12 times 2/3. So 1 and 4, so it's equal t to power 8. So t to power 2/3 is equal to t to power 8. Now x to power 2/3. Now x to power 1/4, that means I have here 1, right? Substitution. So 1, I have multiplying by 1/4, right? To get x to power 1/4, which means same thing I'm going to do here. 12 times 1/4. This is 1, this is 3, and I'm getting t to power 3. Okay. All right, so from here, I'm going to substitute. It is going to be, I need x to numerator, x to power 1/2. Let me take care of this 1/2 also, which means gonna be t to power 12 multiplied by 1/2, right? Because here is 1 times 1/2. And this is 1, this is 6. So x to power 1/2 is equal to t to power 6. Okay, we got it. So here I have t to power 6. Here I have t to power 8. And x to power 1/4 is t to power 3. Now I need to get rid of dx, rather saying express dx by dt. Yes? So dx by dt is equal 12 t to power 4, right? I'm taking derivative t to 12. Okay, let me write down, not to jump step. It's going to be t to power 12 prime, which is going to be 12 t to power 11. And from here, dx is equal 12 t to power 11 dt. Okay, so writing down here times 12. Well, this 12 I can put out. t to power 11 dt. Okay, so what am I getting here? 12. So degree 6, degree 11 is going to be t, degree 17, right? And in the denominator, I can take t to power 3 out, and I will have t to power 5 minus 1. And here is dt. So which means this t to power 3 is gone. This 17 will become 14, right? So let's write out clean. 12 integral t to power 14 over t to power 5 minus 1. Okay. What is going to be next? I could substitute, but I'm going to do the following this time. I'm going to divide t to power 14, divide by t to power 5 minus 1. Take the whole part out, okay? Doing a long division. Whoever doesn't remember how to do long division, search in my at the channel. I think I will put the reference at the end of the screen, long division. So whoever doesn't remember, you can go and watch it. Okay, so t to power 14 dividing by t to power 5 minus 1. So 14, t to 14 divided by t to 5, we have to subtract, right? 14 minus 5 is 9. So we will get t to power 9, correct? So if t to 9 times t to 5, it's going to be t to 14 and minus t to 9. Now when I subtract, this is going to be gone. And the minus, it's going to be t positive t to 9. Okay, t to 9 divided by t to 5, it's going to be t to 4. So t to 4 times t to 5, it's going to be t to power 9 and minus t to power 4. With this subtraction, we are getting positive t4. Okay, we are done because t to 4 is less than here t to 5. And we are getting, let me write down, this is going to be equal 12. And the whole part is going to be t to power 9 plus t to power 4 plus now t to power 4 yet to be divided by t to 5 minus 1 and dt. All right? And dt. Okay, let me clean this drafting. So what do I get here? I'm getting the following. 12 stays the outside practically. It's gonna be 12. I'm going to separate t to 9 dt plus 12 t to 4 dt and then plus 12 integral t to 4 over t to 5 minus 1 and dt. Now this piece I can already integrate, right? Based on tabular formula that it's going to be, okay, let me write down what's going to be. It's going to be 12 t to 9, it's going to be t to 10 over 10, right? Plus 12 t to 5 over 5. Now here, this one is going to be different story. I need to do another substitution here. Now you might ask me why, if that's the case, if I will end up with another substitution, why I didn't substitute right here. And I can hear you are asking this question, and that's absolutely legit question. How can you know when to substitute and when to divide and simplify? I'll tell you that. First of all, t to 14 divided by t to 5, this is improper fraction, right? Why? Because the degree in numerator is greater than degree in denominator. That's one reason. And while here, t to 4 divided by t to 5 minus 1, it's the proper fraction because degree in the numerator is less than degree in denominator. Second reason, if I would substitute, let's say, and take then t to it, I would substitute the following way. U is equal t to 5 minus 1. I'm talking about this one, this case. Okay, and then once I take derivative, du by dt, it would be 5t4, right? And I don't have here 4, so I would kind of use it. But in this case, I do have it. Once I take derivative, I will get t to 4, and you will see how nicely it will work out, okay? So, mainly, I would recommend, once you see it's improper fraction, not to think about substitution and go and divide first, convert into proper fraction first, just like I did here. Okay, let's now work out this t to 4 divided by t to power 5 minus 1. I'm going to work out this piece. Okay, so I'm leaving so far this final answer halfway because I need to work out this last piece, last term, which is 12 integral t to power 4 over t to power 5 minus 1 dt. Okay, this is what I'm going to do. So I took already u is equal t to power 5 minus 1. It's a substitution. I took a denominator, right? T to power 5. Why? Because once I take derivative, I get 5t to power 4, and I have t to power 4 in numerator. Okay? So, from here, du by dt, du by dt is equal 5t to power 4. And from here, du is equal 5t to power 4 and dt. Okay, let's see what we have here. We have t to power 4 and dt. So the difference is only in 5. At this point, I'm going to do this. 12 integral t to power 4 dt, t to power 5 minus 1, and I need 5. I'm multiplying here by 5, and at the same time dividing by 5. We're just taking out because I don't need this 5 in denominator. Take out as a constant. But this piece I need because it's going to be my du. And as a result, I will get 12 over 5 integral. So in denominator, it's going to be u, right? Because u is equal t to power 5 minus 1. In numerator, it's going to be du, right? Now, integral du over u is equal natural logarithm u, right? So here we are going to have 12 over 5 natural logarithm u, which is going to be equal, plugging back our t to 5 minus 1, 12 over 5 natural logarithm t to 5 minus 1. Okay, since I solved this piece, now I can attach to the piece here that was left halfway. So this piece, now we solved it. It's going to be plus 12 over 5 natural log t to power 5 minus 1 and plus c. Okay, so we have so far this answer, and now the final step is move back to our original x, right? To our value of x. So let me write down, rewrite it here again. So, well, okay, I can do it without rewriting. I have 12 t to power 10. So how are we going to back to x? Remember, we substituted x that is equal t to power 12, right? We substituted with t to power 12. Now we have 10. How to go from 12 to 10? The only way you can, do it with multiplication and division. So I'm thinking here, 12, if I divide by 2, no, hold on. If I divide by 2, it's not gonna work. So to get 10, I can divide by what? By 5 and 2, right? So I'm going to write down here times 5. So to get 10. So which means this 12 I have to turn into 2. So 2 times 5 will be 10. Yeah, I'm dividing here. Oops. By 2, I'm dividing by 6. See? I will get 10 here. So which means I am multiplying by 5 over 6, right? Which means x also, because x to power 1, I have to do the same thing with x. I have to multiply by 5 raised to power 5 over 6. So in this case, it's going to be 12 x to power 5 over 6. Are we understanding what I'm trying to do? Let me go over one more time to make sure we understand. I have my primary substitution was x is equal to t to power 12. But here I have only t to power 10. So how to get from t to power 12 to t to power 10? So to get to t to power 10, what I want to do, I'm going to divide by 6 and times 5. How do I figure out? So I need to get to 10. Which numbers I can multiply to get 10? Only 2 and 5, right? There is no other choice. So which means here it's going to be either 2 or it's going to be 5. Yes? If I have here 2, guys, that means from this 12 I have to get 5. And there is no way in the world I'll get 5 from this 12, no matter what I divide by. But I can get 2 if this one I replace with 5. That means 12 I can get 2 from 12. I can do that by dividing 6 by 6. Yes? 12 by 6 is 2 and times 5 is 10. And that's where from I got x to power 5 over 6, because here is 1. So if I do change 5 over 6, that means here also I have to do 5 over 6. All right? Okay, next one. Let me clean. I have 12 t to power 5. Okay, plus 12. Here is 5. Now I need to get x is equal to 12. I need to get t to power 5. To get t to power 5, So 5 is a prime number. There is nothing I can divide or do. So, which means it's I have to multiply by 5 to get 5. That's the only thing. To multiply by 5 to get 5, that's mean here has to be 1. How I'm going to get 1 from 12? All I'm going to do, take this 12 and divide by 12, right? Which means x also, I have to multiply the raised to power 5 over 12. Same fractional degree. Okay, which therefore here it's going to be x to power 5 over 12. And plus, we have 12 over 5, natural logarithm x to 5. X to 5, we already know it. I mean, t to power 5, it's going to be x to power 5 over 12. And minus 1 plus c. And that's it, which means now I'm going to put in the format of radicals. So first of all, 12 and 10 I can reduce, let's say here, by how much? By 2, it's going to be 6, it's going to be 5, right? 12 and 5 here, I can't do anything else, all right. So the final answer is going to be 6 over 5. Now x to power 5, 6, it's going to be radical degree 6, and underneath x to power 5, plus 12 over 5, and it's going to be radical degree 12, yes, x to power 5, and then plus 12 over 5, natural logarithm x to power radical degree 12, x to power 5 minus 1, and plus c. Okay, finally we're done, and this is our final answer after integration. Now let me do this. So our original problem was integral square root of x cubic radical x squared minus radical degree 4x and dx. Next one, integral x squared e to power 3x cubed plus 5 dx. Okay, how we're going to figure out what is going to be substitution portion? Well, when it's come to x squared, we can take integral with no problem, right? X cubed over 3. But the different story is this non-standard form of e to power x. Instead of e to power x, we have e to power the whole expression, 3x cubed plus 5. And I think this is the part we are going to substitute to bring to tabular form, okay? Which is going to be, if I take u, is going to be equal 3x cubed plus 5, okay? From here, we take derivative, du by dx, since derivative of u is 1, so we have left what? Derivative of 3x cubed plus 5, it's going to be 9x squared, and derivative of 5 is 0. And from here, du is equal dx, 9x squared dx. All right, so what is interesting here, look here, I have 9x squared dx, and here also I have x squared and dx. So I need to add this 9. Very easy. E to power 3x plus 5, 3x cubed plus 5, I'm going to write down u, and this x squared dx, since I have there to be 9, then I am dividing by 9 also, and since it's a constant, then I might as well just take out right away. And it's going to be equal 1 over 9 integral EU du. And from here, 1 over 9, and we know that radical of EU, since derivative of e to power x is equal e to power x, then accordingly, integral also e to power x dx, it's going to be again e to power x, right? So here we get 1/9 e to power u and plus c. And that's going to be equal 1/9 e to power 3x to power 3 plus 5 and plus constant. Okay, that was pretty easy, simple one. And now let's do a challenging problem. Free. Integral. We have e to power 2x dx. And here we have radical degree 4, e to power x plus 1. All right, so usually when we have radical, then expression under the radical, we are substituting. And this time also it's not the exception. So we are going to have e to power x plus 1. And interesting, what we are going to substitute with. The thing is, we have e to power x plus 1 to power 1/4, right? Because radical, okay. Let me write down like this, is equal e to power x plus 1 to power 1/4. Since it is 1/4, which means common denominator is 4, that's mean I'm going to take do substitution based on common denominator, and it's going to be e to power x plus 1 is equal t to power 4. This 4 I took from this 4, it's common denominator. Remember in the last video we had common denominator 3 and 4, and the substitution was t to power 12. Okay, this time it's going to be t to power 4. Since, what do we have? We have e to power 2x. To find e to power 2x, first we need to find e to power x, which is equal t to power 4 minus 1. And from here, e to power 2x, we have t to power 4 minus 1 squared. Okay. Next, so we need to, we have dx, right? We need to, so we have 2x, e to power 2x, we express through t. Denominator we express through t, because e to power x plus 1 is t to power 4. The only thing left to express is dx, right? Now, since we have e to power x plus 1 equal t to power 4, so we never had before such substitution, So we have expression, and on the left side and on the right side also we have degree. Therefore, on the right side we take derivative by x, on the right side we take derivative by t. And what is going to happen? We are going to get e to power x dx, right? And t to power 4, it's going to be 4 t to power 3 dt, okay? And that is going to be at our dx, the value dx from here will be equal 4t cubed dt divided by e to power x, right? Okay, and I need to replace this e to power x. I need to have expressed through t. And where is my e to power x? Right here. So it's going to be 4t cubed dt divided by e to power x. It's going to be t to power 4 minus 1. Okay, now let's write out everything. So here we have integral. So e to power 2x is here, t to power 4 minus 1 squared, and then dx is equal 4t cubed dt divided by t to power 4 minus 1, right? And we need cube at the radical degree 4 ex minus ex plus 1. All right, let's see. If e to power x plus 1 is equal to t to power 4, hence when we need to raise to power, because it was 1, now we need multiplying 1 over 4. I mean, degree is 1 over 4, right? Which means here t also, it's 4. I have multiplied 1 over 4, correct? And we get e to power x plus 1 to power 1 over 4 is equal t. 4 over 4 is gone, right? So we get clearly t. Okay, what is going to be here? It's going to be here t. So as a result, this square is gone with this t to power 4 minus 1. This t is gone with this 3 become 2. And the final shape of this integral is going to be t to power 4 minus 1 times 4t dt. And that's it. In denominator we don't have anything left. Okay, this is all we have. So from here we take out 4, right? And it's going to be t to power 4 minus 1 times t squared. 4t squared, that's right. I forgot. This square right here. Okay, and it's dt. So from here, we are going to distribute t squared. This is 4. It's going to be t to power 6 minus t to power square dt, and that is equal 4t to power 7 over 7 minus 4t to power 3 over 3 plus c. Okay, So let me bring back our value of x. So t to power 7. So if e to power, let me see, if e to power x plus 1 is equal to t to power 4, therefore I need t to power 7 to get degree 7, because here it is, see I have 7. So from 4 get 7. There is no way from 4 to get 7, because 7 is a prime number. So the only way to do that, I'm going to divide by 4, meaning get 1, and multiply by 7. So